Yes.
Okay, we're all set.
Okay, everyone, our apologies on not having this right. It is our first hosting of a webinar, and we're going to start now. We won't be able to have a video of Dr. Waxman at this point, but hopefully you can all hear him very well. So co-hosting with me here today is PK Agarwal, who is quite new volunteer in this erythromelalgia community, and he has brought us some really great new ideas for interactive initiatives to improve engagement with the community. He's infused energy, and with that we have reached many of our contacts and started monthly meetups where members of the erythromelalgia community come together to discuss experiences and a monthly topic. And some of you have already participated in those. And if you are interested, please be sure to use our contact page and let us know that you're interested. It's been very successful with people just clamoring for more connection. So that is why we're here today, to start a webinar series. And today's much anticipated and unfortunately delayed webinar features Dr. Stephen Waxman, who is on the phone with me. He is a neurologist and neuroscientist who has an extremely long list of achievements. Just a few of them are that he has served as chair of the Department of Neurology at the Yale School of Medicine. As of 2018, he is the Bridget Flaherty Professor of Neurology, Neurobiology and Pharmacology at Yale University. He founded the Yale University Neuroscience and Regenerative Research Center in 1988 and is its director. He's published more than 700 scientific papers, and his papers have been cited more than 40,000 times. That's a lot to wrap your head around. He's known to many in the erythromelalgia community for his continuing research to understand the mechanism behind nerve pain and the use of EM as an example of this type of pain. Welcome, Dr. Waxman, and thank you so much for taking the time out of your very busy schedule to be with us today.
Well, I'm glad to be here, Beth. I apologize. A question that often comes up is, do scientists collaborate? We do collaborate. We've lived largely on Zoom over these past couple of years, and it usually works. I don't know what went wrong today, but in any event, I'm glad to be here.
Thank you so much. So you're currently heading up a team of 35 scientists in the research center at Yale. Can you tell us your focus?
Sure. Our research center is focused on the general issue of how we can capitalize on the molecular revolution to develop new therapies for individuals with damage to the nervous system. And what we've decided to do is to focus largely on neuropathic pain. It's an immense unmet medical need, and we feel that new therapies and cures are achievable. Our research center is somewhat unique. If you take a job at a university or medical school, usually what's important is academic freedom. You work on what you want. But we have 35 scientists, gifted, energetic scientists in this building, biophysicists, pharmacologists, cell biologists, stem cell biologists, and we trade in our academic freedom to work together on one unified goal, neuropathic pain. And so we trade in our freedom, but we get immense strength working as a team.
That just sounds, wonderful and gives us a lot of confidence. To get into some of the details, can you explain to us what is NAV 1.7, sometimes called SCN9A?
Sure. NAV 1.7 is a sodium channel. There are 9 different types of sodium channels, NAV 1.1 through NAV 1.9. And NAV 1.7 is very important for a couple of reasons. One is it's a master switch, a master regulator of pain. It's sitting there in our pain signaling peripheral nerves, and it works like a volume knob. It controls the volume at which nerve signals are generated and sent from our nerves to our brains. So NAV 1.7 is a major player in neuropathic pain. It's become, largely because of our work, a major target in the biopharma industry. And I don't have to tell people in the erythromelalgia community how important it is. Gain of function mutations that make NAV 1.7 overactive, produce inherited erythromelalgia. And that is a very strong, unequivocal conclusion. But even in people who don't have mutations of NAV 1.7, it is functioning as I said, as a volume knob on our pain signaling nerve cells. And so in every person in the world, it's there as a controller of pain. Very rare families that have what are called loss of function mutations. They don't make NAV 1.7. Those families don't feel pain. And they have a remarkable picture of painless fractures, painless burns, painless tooth extractions, et cetera, et cetera. It's very rare to have gain of function mutation and loss of function mutation of the same gene. In this case, we have it. This is what's called genetic validation. It tells us very clearly that in human beings, NAV 1.7 is a master controller of pain. So it's one of our major interests.
Yes, and I also understand that the molecule NAV 1.8 works with 1.7. Can you tell me more about that interaction?
Sure. As I said, there are 9 different sodium channels. They're like the members of an orchestra playing together. And in this case, they're letting nerve cells generate nerve impulses. NAV 1.8 works together with NAV 1.7, like 2 dominoes, one falls and then the other. And so we don't have a strong genetic validation for NAV 1.8, but we do know that there are some patients with painful peripheral neuropathies who have gain of function mutations of NAV 1.8, and it's also a target for drug development for pain. There is a company called Vertex Corporation. I have not worked with them, but they have developed a series of blockers of NAV 1.8. The first 2 failed. The third one has shown promising results on their first clinical trial. And so that's caused excitement in the pain research community. We'll have to wait. They now want to do a larger second clinical trial, but we're waiting with bated breath. And in my view, an NAV 1.8 blocker would also be useful, as would NAV 1.7 blockers in people with erythromelalgia.
Yeah, it's really amazing to start to get these insights on what's happening behind the scenes. Things that aren't in the news, things that we don't know about, but are all working towards the same end. And in that vein, I've also heard of gene editing. Can you tell us what work you're doing in that area and how it can help with the understanding of pain for those with EM and how it might help those with the EM?
Yeah. Well, so as I said, NAV 1.7 is a master switch on pain. Imagine that you could go into a human being and alter the gene that is making NAV 1.7 channels, so those channels are altered. They're slightly less active. That's what gene editing does. This is a global gene therapy It's not here yet. It's something that we are working toward. We just received a large multi-institutional grant from the NIH to work on gene editing of NAV1.7. That's us, the Marine Biology Laboratory of Woods Hole, Massachusetts, University of Texas, and University of Tel Aviv. And we're bringing the expertise of all these centers together to see if we can edit the gene for NAV1.7. And this is very, very challenging work, but we are moving ahead as rapidly as we can.
And to people with erythromelalgia, to that end, the pace of the research seems slow. And there's, a lot it's not predictable as far as, when we might see some of these initiatives come to fruition. Can you comment on that slow pace?
Sure, I can comment on the pace. So to people with intractable pain, and to me as a scientist studying pain, the pace is slow. It's frustratingly slow. On the other hand, if you think about it, we've progressed at a much faster pace than for some other diseases. The gene for Huntington's disease was pinpointed in 1987. We still don't know how it causes disease, and there are no therapies being tested. The gene for erythromelalgia, NAV1.7, was found in 2004, 2005, and we're already beginning some early stage clinical trials. Is that fast enough? No, but at least against that yardstick, we're moving it at light speed. I think there's another important thing to bear in mind. Pain research has its own challenges. So if you're trying to develop a new therapy for cancer, you can measure the cancer, you can do a blood count, you have a biomarker. If you're working on pain, there is no biomarker. It's a subjective response. You ask the patient, how bad is your pain? From 0, no pain, up to 10, the worst pain you can imagine. I don't have to tell you that's a very noisy measure. It is perverted by sleep status, expectancy, et cetera, et cetera. And in addition, the placebo response is large. And then finally, the animal models, the rodent models, do not predict very well the outcome in human beings. So putting that all together, it means that the science is slow, and then we live in a heavily regulated society. We want to be very, very careful. Safety cannot be compromised, period. But we live in a society that is heavily regulated. The FDA is very process-oriented and moves slowly. And there are just to give you a sense, we worked with Pfizer on the first NAV1.7 blocker, and it took working with Pfizer 9 years. When we did a study here, a clinical study at Yale in-house, we were able to do that in 4 years. We didn't have to deal with patent issues. We didn't have to deal with layer upon layer of administration. But the pharmaceutical industry is much needed in this process, but they move at a slow pace.
Yes, understood. And it's all very costly also, which I have a question about that in a minute. But I did want to ask you one other thing that came up when you and I were having a discussion just the other day. If you could speak to pain resilience and what that means for erythromelalgia patients.
Sure. This is, we think, really important. We've all met the occasional person who appears to have a higher threshold for pain. But in that regard, inherited erythromelalgia has provided us with some very, very strong clues, because we have a small number of families with inherited erythromelalgia. Everybody in the family has the same mutation. They would be expected to have the same excruciating pain, and usually they do. But we have a couple of families in which one individual has very moderate pain. And we've been interested in the pain moderate individuals. What's different? Why is their pain not excruciating as it should be? And so we've studied these people very, very carefully to first document that indeed their pain is moderate. And then second, we're really able to move in exciting ways because of new methodologies that were unthinkable even 5 years ago. So we can take from the various people in these families, and they all have the same NAB1.7 mutation. They all have inherited erythromelalgia, but we can take from them a little bit of blood, and we can make stem cells. And we can, from those stem cells, make sensory neurons with their genes, their 23,000 genes. And we can put them in a dish and study them. And we, for instance, see that the patient with bad pain has sensory neurons that are very hyperactive, like machine gun. The patient from the same family who has moderate pain has sensory neurons that are hyperactive, but not nearly as hyperactive. They're going bump, 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 bump. So now in a dish, we have a model of their pain, and then we can look at their genes. This is very laborious. We go through all 23,000 genes. What's different in that patient who doesn't feel as much pain? What is protecting that person? And we've been able to pinpoint one single gene in one of these and a related gene in the other. It's called KB7.2 and KB7.3. And these are genes that calm down the firing of nerve cells. So these are the first pain resilience genes that have been found. To us, a pain resilience gene is a target. Can we capitalize on that and develop drugs? We're talking with drug developers, and so to us, these are the rarest of the rare. These very rare individuals have pointed in an exciting direction.
Wow. Well, yes, that's the first that I've heard about that. That's so exciting. What a great discovery. So you mentioned that you've collaborated in the past with Pfizer. Are there other pharmaceutical companies that you have collaborated with?
Oh, yeah. We collaborated with Pfizer. We collaborated with a company that they ended up acquiring called Icogen. We've worked with a company called Convergence in Great Britain, and we've collaborated with a company called Biogen. And we're talking with some other companies. So we do view ourselves as part of a pipeline leading from the laboratory, from the gene, to the societal marketplace of where people need us. So that's a very important linkage we have. We also collaborate very strongly with other academic centers. And so the world's hub for patients with painful peripheral neuropathy, not EM, but painful peripheral neuropathy, is the University of Maastricht. We're on the phone or on the email with them or on Zooms 5 times a week because they study their patients and send the mutations to us. We collaborate with University of Oxford, University College London. We collaborate with colleagues at Harvard, and so it's a sort of rich set of interactions.
Yes, and it makes me think of conversations that we've had, us laymen, not in the research world, that, you know, I think we had a perspective that the researchers and pharmas worked in silos. And, just speaking with you throughout this conversation, you've noted so very many times your collaborative efforts. So I think that's very heartening for our community, to not think of the researchers necessarily, hiding and squirreling away their information, and we all know that everything is more productive in a good team environment. And so would you say, Dr. Waxman, that your research is well funded?
I would say it's reasonably well funded. We've been very competitive. We do well at competing for grants. We're funded by the Department of Veterans Affairs. You can imagine why they're interested in chronic pain, and the NIH. And we have gifts from private donors. And of course, we received a gift from DEA some years ago. The private dollars, even if they're small gifts, are worth their weight in gold because they come without the red tape and bureaucracy of government gifts, and they let us test risky new ideas. But putting everything together, we're reasonably well funded. We always could use more money, more facilities, more scientists, but I think we're doing sort of okay there.
Yes, I'm sure it's an extremely competitive environment. Everybody's, we know that the federal government is more strict all the time on how money is spent, and they're so careful. So we understand that there's some sure pressure for you at all times to seek more funding. Do you believe that there will be new treatments for EM?
I'm absolutely confident that there will be. There will be treatments for chronic pain, and in particular, neuropathic pain like EM. I'm absolutely confident of that. On the other hand, I just can't predict when. It's not going to occur tomorrow or next month or even a year from now. But given all of the progress that's being made, both within the academic world and the biopharma world, I'm confident, I'm optimistic that it will happen.
And what besides those things, I'm just trying to, I see some notes that I have here, and one thing that you had said at one point is that there's multiple shots on goal, meaning, and as you've noted for us today, that there's work being done in many, from many different points, coming in with the same target, which is to find relief for this nerve pain. So do you have any parting words for us today, Dr. Waxman?
Well, I think that that's a very important point. Multiple shots on goal. Even a well-conceived idea can fall off of the drug development pipeline. But we're attacking it in terms of small molecules. Those are drugs that would be in a pill that would mute the activity of NaV1.7. Antibodies against NaV1.7. Peptide toxins can be turned into drugs against NaV1.7, and then gene therapy. And then in addition, we and others are looking at NaV1.8. We didn't have time to talk about it, but NaV1.9, and finally the resilience genes. So, there is this multifaceted attack on chronic pain that's going on, and I'm confident that there will be new drugs, and partly, 20 years ago, pain research did not attract nearly as many good scientists as it does now. Now we have a small army of people. Many of them have worked here, now have gone on to their own labs around the world, but there is a small army of energetic, talented doctors and scientists, working around the world. So in terms of a parting message, I know it does not provide the relief that people want today. But what I can tell you is there's hope. It's realistically based hope. And I tend to use my words very conservatively. I used to say there may be a new class of more effective and non-addictive pain medications, and now I'm saying there will be. It's just a matter of time.
Well, that's great to hear your change in terminology, but again, with taking it with the grain of salt that this is still not predictable, and so we still are as a community dealing with nerve pain every day. But the hope is helpful and puts things into perspective for us as we do go through our day-to-day. Dr. Waxman, I can't thank you enough for your time today. My apologies about the confusion at the beginning. We are all just always looking for any news, and this is the kind of news and information that that people are looking for. PK, did you have a comment? Oh, you need to go off of mute. Speak loud.
Yeah. I'd like to also express my thanks to Dr. Waxman for taking the time, and perhaps we could ask him to.
Can you speak a little louder, PK? He's having some trouble hearing you.
Okay, let's see if this helps. Is that better? Is that better?
I don't think so.
No, sorry. Can you hear me, Beth? Can you hear me okay?
I can hear you, but you're quite quiet.
Yeah. Could you turn up your speaker volume?
They're all the way up.
Well, maybe I'll just speak to the audience then, because I think this is about as loud as I can get here. But I just wanted to thank Dr. Waxman, and on behalf of all of us at the association, we'll ask him if he would be gracious enough to come back, visit, give us hope, and give us a progress report in about a year and a half, so we keep track of it. But if the big takeaways for me is the fact that there is research going on. There are specific genes and the resilient genes that are identifiable, where the sort of the real progress happening. So there's reason to assume that, as Dr. Waxman is optimistic, so are the rest of us. And I also wanted to point out that since pain and chronic pain is a big issue, we do have another webinar coming up on October 12th on chronic behavior therapy, CBT, for pain management, which is becoming a very effective tool in the business of pain management, as it helps reprogram the brain essentially to do that. So I just wanted to.
Oh yes, I definitely have that. I do have my own parting remarks, and I know that is something we really want to let everyone know about. And Dr. Waxman, I apologize for a little bit of the low audio, but PK was extending his gratitude for you being here, and he'd like to invite you to come back in a year and a half with updates. So we'll reach out, of course.
I'll be glad to follow up.
Okay.
Yeah.
Great. Thank you so much. Yeah, so I just want to add, a few comments. I was having a really great discussion with Dr. Waxman last evening, and one of the things, that we, that he gave me a lot of understanding around is that it's impossible to predict a timeline for seeing an approved treatment on the market for our patients. But at some point, there's no doubt there will be. But in the meantime, there is a need to stress, to the audience and all of those suffering with erythromelalgia to keep working with their doctors, either forging good relationships with current docs or finding the right doctor who's willing to work with you to try the various meds that are already out there. Each one helps only a few, but if you found one that, helped you, that would be the way to go right now. And also the coping mechanisms, the day-to-day modification of behaviors, to take care of yourself, and don't wait for the research and the new meds, because it's going to be a while. So you have to really be your own best advocate and researcher, exchanging anecdotes with others who have experienced erythromelalgia. These are all very good things for you to do today. And as a plug to the Erythromelalgia Association, you can do a lot of that through us. We have our patient's guide, which you can take with you to your doctor. That's available at our website. Our website also features frequently asked questions. There's a member directory and member stories. So you can meet other people. You can read about their experiences. We have past newsletters with all types of information. And so you could spend a lot of time doing your own research and knowing that you are not alone. And finally, as an additional note, what PK was saying is that on October 11th of this year at 11 a.m., we will be hosting a second webinar with a cognitive behavioral therapist from the world-renowned Beck Institute. The intent of this webinar is to introduce methods that we can use to reduce pain by changing the physical response in our brain that makes the pain worse. A lot of that is stress and that type of thing, and kind of re-educating ourselves. Not that it erases pain, but it can reduce pain. So more information will be shared about that webinar via email announcements in the coming months. And, again, we apologize for the issues at the beginning. We have recorded this, and we'll make this available for friends and family and others who couldn't attend at a later date. Thank you all, and have a really great rest of your day.
Bye-bye.
Thank you, PK.
Bye-bye. Thank you.